basic research. The first industrial revolution was triggered by theoretical advances in mechanics and thermodynamics. Dennis Papin built the first model of a steam engine. Joseph Black discovered latent heat, making it possible for James Watt to improve the steam engine further. We began to power vehicles with machines. Traveling 1,000 miles a day was no longer a distant dream. With machines, we could travel to faraway places faster than horses and sailboats ever could. Electromagnetism provided a theoretical basis for using electricity, which ushered in the electric era. Hans Christian Ørsted discovered subtle relationships between electric currents and magnetic fields. Michael Faraday published his discovery of electromagnetic induction. Thomas Edison developed the first long-lasting incandescent light bulb, lighting the way for a brand new industry. Electricity soon became
Is your data always silent? When looking for the within value hidden within big data, traditional databases and storage technologies only serve to make the process more challenging. But now, there's me, the best treasure hunter in the age of intelligence. I was designed for the era of 5G internet. I was made to live in the era of 8K, AR, VR applications. I was born to process real-time data in the AI era. My mission is to uncover the hidden value and buried opportunities to unlock.
Hi, and welcome to the third day of our Industrial Digital Transformation Conference. In this session, we're going to dive deep into data storage and discover what it looks like in the 5G era, where the requirements for data handling and data processing are literally unprecedented. I'm going to say no more and hand things straight over to Huawei's Kendall Chilton, CTO of Intelligent Data and Storage Domain.
I will be presenting the Huawei storage solutions for the 5G era. Huawei began its storage efforts in 2005, 15 years ago. Today, there are over 3,600 engineers working in Huawei storage. They work in 12 R&D centers located throughout the world. They have produced over 800 storage-related patents. Their success is evident in the success of their product in the marketplace. Huawei is #1 in China for external controller-based storage. Huawei is also the fastest growing solid-state storage vendor in the world, growing at nearly 50% year over year, as evidenced in the Q3 2019 data. But there are new challenges that lie ahead. For Huawei and our customers, we are entering an era of explosive data growth. We call this the 5G era. Customers that are engaged in autonomous driving applications are already experiencing 64 terabytes every day being generated in training data. Customers involved in digitizing their factory operations are seeing 1 petabyte per day in data. Customers who are implementing smart cities are even experiencing higher volumes of data. The city of Shenzhen, for example, has 2 million cameras, and they are receiving 80 petabytes per day from those cameras. Enterprise IT used to talk about terabytes, but now the conversations are only about petabytes. But even with all of this massive data growth, less than 2% of our data is actually stored, and less than 10% of the data can actually be utilized to bring us value. These are things that will have to be dealt with in the new era, and Huawei has an answer. When we look at data in the data center, there are 3 different kinds. First, there is production. Production depends on performance. If there isn't performance, you can't satisfy the workload that your business needs. But this workload is not constant. There are often unexpected surges that your data center must accommodate. Beyond that, this is data that must always be available. These are mission-critical operations, and downtime can mean millions of cost or billions of dollars of cost for your data center and for your business. So it's absolutely critical that these systems remain fully functional and available. There is also in the data center another type of data, and we call this big data in video. This is where the data volume is growing faster than the technology is growing. The storage systems are growing at a fairly fixed rate, but the volume of data is increasing astronomically. Not only are we increasing the volume of this data, but we are required to retain it for longer periods of time. Customers that used to store data for 3 months now are expected to store it for 12. And that is fairly short compared to other customers who want to store it for up to 7 years. That's a massive amount of data to leave lying around. And of course, they want to be able to extract the value of that data. So it is not only the volume of the data, but also they require a high degree of bandwidth. A third type of data that is evident in the data center is the edge. The edge is new to many customers, but the edge is going to become a big part of our lives going forward. New applications are appearing at the edge every day. IDC has indicated that by 2025, 75% of all the data generated will be at the edge. This is a big change for data centers. And again, Huawei has a solution. Huawei has invented the one storage, one lake architecture that redefines the data infrastructure. This architecture begins with a converged storage solution. This converged storage solution has one copy of the data. Instead of having multiple copies of the data, it makes the decisions as to what is necessary for performance and replication to meet your business SLAs. So data storage is provisioned according to those SLAs and automatically allocated to the resources based on the demands on that data. In this way, average resource utilization rates can increase from where they are today at less than 40% to more than 70%. And that will result in a savings of more than 30% of TCO. This architecture, the one storage, one lake, is also intelligent. Through automation, it is able to perform lifecycle management and also intelligently manage the data in the intelligent data management system that handles the planning, allocation, maintaining, and optimization of storage resources. Being fully automated, it's able to improve management efficiency by up to 5 times. This architecture is also open. It uses an open data engine, so we can realize the one directory, one interface, and one piece of data vision. Only through open architectures can the customer get the true efficiency that he wants out of his management environment. With this system, data analysis time and time to market can be reduced. In fact, customers have found that by using open APIs, they're able to reduce their time to market of their applications by 80%. So there are several key components to this architecture, and today I'm going to look at 4 of them. First, OceanStor Dorado v6. Second, OceanStor Distributed Storage. Third, Fusion Cube. And fourth, DMS Intelligent Data Management. So first, the OceanStor Dorado. OceanStor Dorado v6 builds on the successful legacy of OceanStor Dorado v3. In the 5G era, there will be massive amounts of data. But in the customer's data center, production data also needs performance. The performance of the systems must keep up with the customer demands. For example, in the carrier industry, their billing systems will increase from about 120 million transactions per million users to about 750 million transactions per million users in the 5G era. This billing frequency is about a 6.5 times increase. This requires faster systems to respond to this workload. In addition, this billing service cannot go down. This requires 24/7 operation and an ultimate reliability in the storage infrastructure. Huawei's OceanStor Dorado v6 is able to deliver 20 million IOPS with 0.1 milliseconds of latency. This is only possible through Huawei's exclusive FlashLink performance acceleration technology. Using their own self-developed CPUs, AI chips, and SSD controllers, Huawei is able to deliver performance that makes the Dorado v6 the fastest all-flash array available in the world. In addition to performance, the Dorado v6 also has the highest availability of any all-flash array in the market. The Dorado can actually withstand 7 out of 8 failures of their controllers. In other words, if you lose 7 controllers in an OceanStor Dorado v6, you can still keep your business running. You still have access to your data. This is extremely important for mission-critical applications. Customers who have experienced the OceanStor Dorado v6 have shown that their billing time has decreased from 10 hours to 3 hours, achieving a 70% reduction in runtime. A second very successful product in Huawei's portfolio is the OceanStor Distributed Storage. This year, Huawei will be launching a new Pacific High Density Capacity node. This ultra-high density system can store almost twice as much data as in previous installations. The high capacity node will house 120 disks in a 5U space. This is industry leading. A unique butterfly wing design enables the disk enclosure to be withdrawn from both the front and the back side of the system. This greatly increases the capacity of insertable disks. This, in conjunction with the large capacity disks, is what will deliver that doubling of capacity. EC technology available only from Huawei achieves the industry's highest data utilization rates, 91%. This would be compared to like 3-copy, where you only get 33% efficiency, or in certain RAID technologies, 67% of utilization of your raw capacity. Huawei also has a unique AI fabric technology. Huawei is the first company to embed AI within the switch. Huawei has iLossless, which is an intelligent lossless exchange algorithm which achieves a true zero packet loss network. And it also provides microsecond level end-to-end latency. This completely breaks the bottleneck of massive data transfers between nodes in a distributed storage system. This alone provides 15% of the Ocean Store distributed storage's performance. Huawei's intelligent coding technology achieves a reduction in power. For instance, disk hibernation and intelligent fan speed regulation decreases the overall energy consumption by 50%. A third product that we can talk about in the Huawei portfolio is Fusion Cube. Fusion Cube 1000 and Fusion Cube 2000 are already very successful products at the edge. This year, Huawei will be introducing Fusion Cube 500. 75% of the data coming from the edge is staggering, and Huawei has created these solutions specifically to address these edge requirements. These scenarios include IoT, smart cities, smart campus, remote office and back office applications, manufacturing, mine safety, healthcare, transportation, carriers, and much more. These systems provide all of the needs that you have at the edge, including compute, based on the Kunpeng ARM CPU and Huawei's AI engine, a storage system, network, firewall, and UPS, all contained within one system. The Fusion Cube 500 is small enough to be a tower unit that sits on your desk. It also can be deployed as a 5U rack mount engine. One of the most staggering features and game-changing features of the Fusion Cube 500 is that it is available in a non-data center environment capable appliance. It does not require data center level ASHRAE specs, which makes it entirely suitable for the back office and for the edge. And of course, it has to have management that unifies with the rest of your data center. In the management area, Huawei has a strategy and a solution called DMS. DMS concentrates on reducing OpEx by using AI to automate storage management. The rest of the wonderful technology and speed and reliability are not very important if you can't manage it. And so it's very important that we're able to manage our systems going into the future. Unfortunately, the methods that we use today will no longer work in the future. There just isn't enough people to hire to maintain a 5x growth in data center storage. Something has to change, and that change is intelligence. We will be deploying AI through an engine we call DME. DME will automate the tasks that will reduce planning, deployment, O&M, and will optimize storage assets to ensure that you're getting the maximum value out of your investment. DME will result in about a 20% reduction in initial investment by finding resources in your data center that can be used more efficiently. It will improve deployment, provisioning by 10x because all of those services can be automated. It will provide a 60% improvement in fault rectification by identifying faults proactively and also reducing debug time to seconds. It will be able to increase your resource utilization by 80%. Again, by being able to locate the resources that are being underutilized, but also finding extra copies of the data that can be reduced. DME is a game changer in the data center management ecosystem. So let's look at some use cases. A bank had a problem. Their utilization rates on their CPUs was up to 93%. A lot of operations were not completing in real time. They deployed the Ocean Store Dorado in their data center and realized a 2x improvement in system performance. No longer did they have a fear of the peak pressure and the bursts in trading activity because the Ocean Store Dorado is able to deliver a consistent 0.1 milliseconds of response time. And of course, being able to stay operational 24/7 is of paramount importance if this is what your business depends on. And for the bank, their core banking business was their business. And the bank has the trust of Huawei to deliver on this solution. Another use case is a big data scenario. A customer came to Huawei with a big data situation. They needed to save cost and expand their big data solution. Huawei solved the problem by separating the storage from the compute. They were able to reduce what was 15 cabinets down to 8. That resulted in a TCO savings of just 40% alone. That doesn't even take into account the performance improvements that they have from this change. A third use case is one of great importance. Mission critical systems is one thing, but when it comes to worker safety, it's quite another. A customer has a mine where the workers are working 1 kilometer below ground, down a roadway that is 20 kilometers away. In the mine, they have more than 200 cameras and over 2,000 sensors. These cameras and sensors must be evaluated in real time to look for faults, problems, and situations that develop that impact customer safety. Huawei was able to deliver an edge solution that is able to accomplish this task in real time and keep the workers safe. Huawei recognizes that through technology openness, we all win. Open source is the way of the future. Huawei has completely embraced open source and open APIs so that customers can work with the systems in a very free manner. Additionally, Huawei has embraced partners in the industry. Through cooperation with other businesses, we're able to satisfy customer needs. Huawei also works with standards organizations and alliances to make sure that we're all on the same page when it comes to the technologies that we develop. By using these three strategies, Huawei engages in shared success for us, our partners, and our customers. And we have a true win-win for the industry in building a data infrastructure. And this data infrastructure is the one storage, one lake architecture that Huawei has developed to solve the problems in the 5G era. Thank you.
Big data is a big waste if you don't have the ways and means of harnessing its value. How your organization handles it, mining it for value, is going to be vital for business success. Extreme performance, full reliability assurance, and lower TCO for your most critical services. But don't just take our word for it. Tony Palmer, Senior Analyst at ESG, is about to explore the full capabilities of all-flash storage on your behalf.
Hello, and thank you for joining me today for this discussion of ESG's technical review of Huawei OceanStor Dorado V6 All-Flash. My name is Tony Palmer, and I'm a Senior Validation Analyst with Enterprise Strategy Group. ESG is an integrated IT analyst, research, validation, and strategy firm, and our goal is to help our clients and their customers achieve business results through our research and advisory services, consulting, and custom content solutions. Before we get started, I'd like to talk a little bit about storage trends that we see in our market research. Basically, flash is everywhere. In 2019, 88% of organizations surveyed by ESG said that some percentage of their on-premises applications and workloads leverage flash-based storage. 71% of those organizations are using or planning to use NVMe-based flash. Organizations who say data is their business or plan to offer a data-centric product in the next 2 years are deploying flash on more workloads. In fact, they're nearly 16 times more likely to deploy flash for more than 40% of their apps and their workloads. These same organizations are 36 times more likely to have already deployed NVMe-based solid state. Simply put, nearly everyone who sees a correlation between data and business results is using flash for their on-premises workloads. Organizations are facing numerous challenges in data storage, according to our research, and the underlying issues that are driving these concerns are consistent year over year. Data growth is accelerating, and the resulting infrastructure required to store and protect that data is getting more costly and complex. Flash storage has been leveraged to try and address some of these challenges for quite a while now. We asked Flash users what benefits their organization has realized as a result of deploying Flash storage. Improved application performance was the most common response, cited by 48% of our respondents, closely followed by improved total cost of ownership and improved resource utilization. So we asked participants familiar with NVMe to identify which objectives were the motivation behind their interest in the technology. The most common response was a desire to overall future-proof their environment, closely followed by improving the performance of existing applications, and other factors like cost optimization, storage consolidation, and reduced operational expenses were also often cited. So lots of really good, strong reasons why people are motivated to move to NVMe. CIOs have told us that they love NVMe technology and can't wait to deploy it. When we asked if they've determined which applications need that performance and where they would deploy it, they said they just want to provide the most performance storage across the entire environment, across their whole infrastructure effectively, to remove bottlenecks everywhere without having to spend resources profiling and troubleshooting applications, right? They can just let their app teams make apps and know that the storage is not going to be the bottleneck. We performed hands-on testing and validation of the Huawei OceanStor Dorado V6 all-flash storage. Testing was designed to validate the performance, reliability, data management, and total cost of ownership of the OceanStor Dorado storage platform, with a focus on delivering high levels of predictable performance to Tier 1 mission-critical applications. We tested OceanStor Dorado's ability to sustain these performance levels through various storage hardware failures and planned maintenance windows. And we looked at the automated data management capabilities of the platform. And finally, we performed a 5-year TCO analysis. So the test bed that we used to test performance and availability consisted of 12 Huawei Fusion Server RH series rack servers connected to redundant fiber channel switches via 16G fiber channel. The switches were connected to one Huawei OceanStor Dorado 18000 V6 storage system with one controller enclosure containing a total of 4 controllers, and 4 disk enclosures that were populated with a total of 41 1.92 terabyte NVMe SSD modules. An Oracle Rack 18C Enterprise Edition cluster was deployed on 12 physical servers with 6.8 terabytes of capacity allocated across 20 volumes. OLTP testing was performed using the Swing Bench and Slob benchmark tools, and we leveraged the Huawei OceanStor Device Manager interface to manage the environment and monitor the tests. First, we ran an OLTP workload with one database instance using the Slob benchmark utility. The workload was configured for 75% reads and 25% updates. Once the warm-up was complete and the workload stabilized, we let the workload run for 30 minutes before we measured performance. As seen here, the system was servicing about 220,000 sustained IOPS at an average response time of just 81 microseconds. Now, 81 microseconds is extremely low, especially for a real application, and especially at this level of performance, and it's among the lowest we've seen for an all-flash storage system. Low latency is critical, since storage latency can have a direct impact on application performance, which can impact the user experience and customer satisfaction. Next, we tested a decision support analytics workload using Oracle Rack and the Swing Bench utility. This test was designed to emulate the key aspects of a decision support system, including complex queries and data maintenance. Again, we let the test run for 30 minutes after the warm-up was complete, and then measured performance. So as seen here, the Ocean Store Dorado 18000 was able to service more than 846,000 IOPS with under 500 microseconds response time. Performance and scalability are key concerns for organizations leveraging data for their business. Faster solutions enable modeling with larger data sets and gaining valuable insights more quickly. High-performance database processing is really a mainstream requirement for data-centric businesses. Huawei Ocean Store Dorado can accelerate data processing across many applications, from genomics to IoT to seismic analysis to predictive and prescriptive analytics. Huawei provides the foundation for organizations to become more agile and begin to align IT with their business goals. Next, we tested the impact of snapshots on performance. With the database workload still running, we created a protection group and added all 20 volumes in the Oracle RAC cluster to it. Then, we configured HyperCDP to take a snapshot every 3 seconds and set the retention to the maximum of 60,000 snapshots. Now, it's really important to note here that 60,000 is the retention limit for a single volume. HyperCDP can manage up to 2 million total snapshots. Now, as seen here, when HyperCDP started, there was zero performance impact. We ran the workload for 30 minutes, and performance remained steady at more than 840,000 IOPS and less than 500 microseconds response time. HyperCDP created more than 12,000 snapshots during this test. This matters because organizations need their data to be protected, but they don't want to pay a penalty for it. Huawei Ocean Store Dorado simply offers penalty-free snapshots to enable continuous data protection with no compromise to performance. The Huawei Ocean Store Dorado V6 all-flash storage platform is designed to ensure high availability and sustained performance through both planned maintenance and unplanned outages. Huawei's implementation of RAID TP can tolerate up to 3 simultaneous disk failures. Parity data and hot spare space is spread across all disks in the storage pool, which decreases reconstruction time and increases storage availability to better ensure continuous data access. Ocean Store Dorado V6 can house from 2 to 32 controllers running in active-active mode. Huawei's Smart Matrix architecture supports full interconnection between front-end interface cards, controllers, and back-end disk enclosures, and can tolerate the failure of up to 7 out of 8 controllers. Cache triple copy and continuous mirroring software features enhance fault tolerance and help ensure uninterrupted business continuity. HyperMetro provides a gateway-free active-active high-availability solution between Ocean Store Dorado systems, either in the same data center or different data centers that are up to 100 kilometers apart. First, we looked at RAID TP rebuild times. With increasing dataset sizes, fast rebuild time after a disk failure or replacement is critical. With the OLTP workload running, we pulled a disk from an array populated with 36 disks that hosted a 7.1 terabyte volume and replaced it to simulate a disk failure. The actions performed by the array to rebuild the data from the failed disk and the elapsed time are shown here. When the array detects the replaced disk, the reconstruction process begins. The rebuild of the 7.1 terabyte volume took just 6 minutes, which is 33% faster than the Ocean Store Dorado V3 we tested in 2018. Next, we pulled 3 controllers while the system was servicing an OLTP workload using VDBench. When we started the test, the system was servicing about 200,000 IOPS with an average response time of 18.5 microseconds. We powered off controller B, then A, then C to see how Dorado would recover. As we pulled each controller, the remaining controllers took up the slack, and response time peaked at 115 microseconds. When controllers A, B, and C were all offline, controller D was servicing the entire 200,000 IOPS workload at 18 microseconds response time. So then, we powered up the down controllers one at a time. As the controllers came back online, traffic was evenly balanced. It's important to note that the system never stopped servicing I/O, and response time averaged under 20 microseconds across the entire test. This is really important both when recovering from an unplanned event and when executing planned maintenance like a software update or an in-place controller upgrade. Next, we tested Hypermetro in an on-campus setting. With two ocean-stored Dorado V6 systems, we called System A and System B, configured as a Hypermetro pair in different areas in the same campus. We began by running an OLTP workload on an Oracle 12c rack cluster, and each server was dual attached to the SAN and zoned to have access to both controllers on each array. The two arrays were connected via dual FC links to each other. We simulated a failure by pulling the power cord of System B. This shows how the storage responded after Hypermetro moved 100% of the workload onto System A. When System B lost power, there was a brief drop in I/O, and the response time peaked at 4 microseconds, then quickly settled back to 100 microseconds, and all I/O was being serviced by System A. We powered System B back on and watched as Hypermetro automatically recovered. All writes that it accumulated during the outage were synced back to System B completely non-disruptively, and I/O never stopped. Finally, to calculate TCO, we modeled and compared the storage-related costs that could be expected when deploying traditional hybrid storage with SAS-based SSDs and disk, and a Huawei OceanStor Dorado V6 with NVMe SSDs. The costs associated with purchasing, maintaining, powering, and cooling the storage systems were calculated in US dollars. The average cost for electricity for businesses in the United States was used to calculate power and cooling costs. Over 5 years, the TCO for the OceanStor Dorado 5000 V6 is just over $150,000. Which is significantly lower than the hybrid array. Cost savings were similar across all three measured categories: hardware and software, maintenance and support, power and cooling. We calculated that the OceanStor Dorado V6 would provide a 78% overall TCO savings over 5 years. And it's really worth noting here that given the availability features of the Huawei OceanStor V6, IT operational costs should be lower as well. Based on our research and experience, SSDs encounter fewer storage failures in the field, which translates into less time and resources spent replacing disks. ESG confirmed that the OceanStor Dorado V6 sustained more than 220,000 IOPS, with an average response time of just 81 microseconds. When we scaled that workload up to a 12-node Oracle rack cluster, we confirmed nearly 850,000 IOPS with an average response time of under 500 microseconds. We were particularly impressed with the ability of the system to sustain high performance and continuous data availability with sub-millisecond response times through multiple controller and disk failures, through fast RAID rebuilds, and through the failure of an entire system using Hypermetro. The results showed that the 5-year TCO of the OceanStor Dorado is significantly lower than a hybrid storage array in capital outlay, maintenance, and support contracts, as well as power and cooling. In closing, data growth is accelerating, and the resulting infrastructure required to store and protect that data is costly and complex. IT is feeling pressure to provide advanced solutions that can seamlessly scale both capacity and performance with continuous availability. In our testing, the Huawei OceanStor Dorado delivered consistently high performance at extremely low response times. It's clearly well suited to support demanding real-world business applications running in a performance-critical environment. Huawei has clearly designed OceanStor Dorado around the dual goal of solving business problems as well as storage problems. It's no surprise that our 5-year TCO analysis demonstrated that by deploying an OceanStor Dorado with NVMe rather than an alternative hybrid storage system, organizations can lower their storage TCO by up to 78%, while improving availability and reducing operational effort. If your organization is looking to lower storage TCO while increasing performance, ESG recommends investing in a next-generation all-flash array, and Huawei is definitely worth serious consideration. Thank you very much for your time and attention today, and please let me know if you have any questions.
It's important to everyone at Huawei that we're open, honest, and transparent. That's why we feel it's so vital for us to work with third-party experts and opinion leaders to hear how we can do better. We just heard from ESG's Tony Palmer about the capabilities of all-flash storage. Now, let's hear from Carsten Rosenhovel of EANTC for a technical review of all-flash storage, especially in terms of VMware interoperability.
Hello, I am Carsten Rosenhovel from EANTC, the European Advanced Networking Test Center. I am the CTO and co-founder of EANTC, which is an independent test lab based in Berlin in Germany. We are running tests for service providers, for manufacturers such as Huawei, and for enterprises and governments as well. And we're completely independent, like we're not partnering in sales with anybody, we have no exclusive partnerships, we're independently owned and so on. Our technology areas are mostly focusing on innovative technologies in the networking space for enterprises and for carriers. And to this end, Huawei has commissioned us to conduct a test of the latest storage solution interoperability. So we're focusing a lot of our tests on cloud scenarios, on network functions virtualization, on software-defined networks, and all of the innovations in the cloud, whether private or public clouds. So before we start with the actual test, what is the trend? What are the trends of private cloud management? Obviously, many enterprises have private cloud installations in their premises. And what they find is that they have different management suites for the compute part, for the networking part, and for the storage part. So in the end, the operators sit in front of different screens, managing the VMware solution, for example, on the compute side, managing the storage, managing the network, the data center switching separately. And that, of course, is quite a burden for an enterprise who does not want to have like all of these people sitting there full-time just monitoring different management applications. So operating an integrated management solution for compute, for storage, and for networking would be much better. And it would significantly reduce the operational overhead, obviously. It would reduce the troubleshooting time because any problems can be seen on one screen and much faster analyzed and resolved. It reduces the training efforts because people don't have to be trained for different management platforms. And it also improves the agility of the provisioning process. And that's, I think, from my point of view, one of the most important ones because there are no inconsistencies, there is no time spent in provisioning things over 3 different platforms consistently. Whenever some new workload is set up in the private cloud, like a virtual machine, for example, a VM, then of course the VM needs to be provisioned, the storage needs to be provisioned, and the networking access as well. So if we can integrate that, things will become much better. Now, Huawei has commissioned us to test the interoperability of the latest Huawei Ocean Store Dorado version 6 all-flash storage solution with existing solutions for cloud management on the compute and networking side. Obviously, the choice here was to test with the VMware ESXi solution. So we built a data center, a typical data center, however, although a small one, of course, for the test, with 2 emulated data centers, each running 1 compute node, with fiber channel switches from Brocade, connecting the storage to the compute nodes using fiber channel Gen 5, and with the Huawei Ocean Store Dorado version 6 solutions set up in a redundant environment on both data centers and running a quorum server here for the agreement like which of the storage solutions should be primary and backup at any time. So with this testbed, we ran a number of test scenarios to verify the interoperability and the performance and overall smooth functioning of this solution. So we started by verifying the operational efficiency by enabling the VMware administrators to manage the storage as well. So we integrated the Ocean Store into the VMware, and we made sure that these resources from the storage can be accessed centrally using the VMware vCenter console. Then we confirmed the high availability features. So we actually switched off one of the Dorado solutions, we cut off some links, and we ran a variety of high availability scenarios to confirm this active data center design and to make sure that failover and recovery would work at any time consistently. So once we did that, we also wanted to see some special functions implemented by Dorado Ocean Store. And these are specifically hardware offload for high intensive functionality. And for example, one of the things that one typically does in a VMware environment is to clone data regions. Let's say if a VM is copied, its image is copied for backup purposes, for vMotion purposes, for any other purposes, then the data needs to be cloned. And that takes a lot of time if the CPU is involved. So there's a lot of data transfer between storage and compute, and it takes a lot of effort and keeps the CPUs busy. Now, what the Ocean Store Dorado solution can implement is actually to offload all of this cloning and VM migration by just having the VMware ESXi send one command like please clone this image, and the rest of the whole operation is done offloaded only inside the storage. So it keeps the CPU free for additional different topics. So we verified that this function is actually working and is interoperable with the VMware ESXi. We verified the VM migration is completely offloaded, and we also verified that the space reclamation, like zeroing space and making it available securely for other VMs without keeping the old bit patterns on the storage, is also done offloaded. We witnessed all of these scenarios here, by the way, with 3 different versions of VMware ESXi and vCenter. That was the 6.0 software version, the 6.5 and the 6.7. These 6.7 is the latest one, and the other ones are still widely used in the industry. So we wanted to make sure that independent of the different VMware ESXi software solution versions, the functionality and performance is always provided. Now, furthermore, we verified the complete integration of the functional parts of the VMware solution with the appropriate Huawei plugins. So Huawei has created plugins for each of the different consoles and services, like the VMware vCenter web client, which is using the Huawei NGC plugin. Then for the VMware vRealize Orchestrator, VRC, using the respective plugin, the Operations Manager using another plugin, and finally the Site Recovery Manager, SRM, using the Site Recovery Assistance plugin. So all of these are little pieces of software that integrate with the VMware solution, and again, as said in the beginning, provide a unified view and allow the operator to really manage and operate and maintain all of the functionality across the storage and the compute within from the VMware tools point of view. And so that was basically mostly on the high availability side. On the management side, another thing that we also verified was that the operations would be stable. This was not a full-blown test. Of course, we didn't run any major benchmarks of storage here, but we at least ran high input-output operations per second test, IOPS test, a stability test by running a soak test for 12 hours straight. So we set up a high throughput scenario, really challenging the storage to the max, and we ran it for 12 hours to make sure that the whole operations would be stable from the data plane perspective and also from the management plane perspective. And this was the case, so we can confirm that the solution is stable in this 12 hours soak test as well. So, in summary, the Huawei hardware storage is able to speed up the VMware operations by offloading these storage operations to the array. as I said before, so cloning, VM migration, zeroing, these are all done things offloaded which help to speed up the whole scenario. This function obviously reduces the overhead on the compute nodes, and it improves the performance as well, because the zeroing and cloning is done much faster if the storage can take care of it by itself, rather than the CPU having to deal with it. And across the whole test, we successfully verified, and Huawei demonstrated successfully, the different capabilities of discovering the resources of storage in VMware, of managing these storage assets, of monitoring everything that was going on, replicating data, orchestrating all the resources, and doing site recovery management. So all of these functions here, some screenshots showing the VMware vRealize Operations Manager and the orchestrator, showing the plugins, how they're integrating here, were confirmed. And all in all, we can confirm that the interoperability between the Huawei OceanStor Dorado version 6 all-flash storage and the VMware solutions 6.0, 6.5 and 6.7 can be confirmed. So thank you very much for your attendance. I hope the test is useful. Of course, we have a much more detailed test report available for download, and we hope that you will benefit from reading it. Thank you.
In 1987, the year Huawei was launched here in Shenzhen, Japanese giant Sony launched DAT, or digital audio tape, just its latest innovation in recording media. Indeed, Sony released its first magnetic recording tape way back in 1950. So, who better to turn to in search of insight? Let's hand over to Sony Europe's Walter Korda, who's going to explore innovations and applications for third-generation optical disk-based storage when it comes to archiving data.
My name is Walter Korda, and I am a technical specialist of Sony for optical disk archive. The data storage market trend is showing an enormous increase in the amount of data being generated worldwide. The figures for the next years are impressive, and we actually need to relook at this trend every year, because the way it moves is going behind any expectation. We have several examples from the industry, and we will now analyze some of the most interesting, but of course there are many segments where data is being generated continuously. A very interesting one is that coming from the auto vehicle industry. The possibility of autonomous vehicle with intelligent drive is actually seeing cars filled with sensors. All of these sensors are generating a very large amount of data per day, and this data is being collected and sent to the AI engines, which receive the data, process it, and analyze it for improving the AI software and routines for the next generations of cars each time. So this industry is actually generating itself an immense amount of data, which actually needs to be collected and stored somewhere. We have another example from the astronomy area. One observation data for a black hole M87, for example, has generated 350 terabytes per day, so over 5 petabytes. All of this information needs to be stored somewhere safely, because we often need, especially in this area, in the astronomy, need to analyze the data in a very long span of time. Even supercomputing is also another area where we generate a lot of data. The calculations and the results are kept for years and are needed by supercomputers. We have another example from the medical industry. In the medical industry, today's technology allows us to go very deep in the study of DNA. We can sequence the DNA, we can do scanning electron microscope, we can do confocal microscope. All of these machines are generating a very large amount of data. And again, we need to store for future retrieval and also to make it available to many scientists around the world for studying and increasing the knowledge in these segments. So in the worldwide storage market trend, as we have shown, there is a very increase, there is an enormous increase in the quantities of data being generated, but data is not all the same type. We actually, in fact, identify the hot data. The hot data is the data that we need to access instantly because we need it in this moment. And for this type of data, we prefer, for sure, to use a storage like a solid-state drive. This storage is very reliable and very fast, at a premium cost, of course, but we are very happy to pay for this extra cost when we have the access performance, which is instantaneous. We then identify a warm storage. The warm storage is something less important, where we need less speed compared to the hot storage. Then here we can, of course, accept the performance of a traditional hard disk drive, and this is why also this is the technology that we use for the warm segment. And we then identify the cold and frozen data. This is actually a very large part, probably is the largest part, largest amount of data that we are dealing with. Okay, for this segment of data, this part of data, we have been identifying at least two technologies available which suit the needs for accessible long-term storage, reliability, low cost, and gigabyte and total cost of ownership. At least two technologies. One is the optical technology and the other one is the tape technology. The issues to be solved for data archiving. This is a very important slide. So the capacity, for sure, is one of the first elements that we consider when we are talking about the capacity of a media. So here is important the size of each file that we are going to archive. If we are dealing, for example, with just TXT files, or if we are dealing with 4K video or broadcast archive or cold data, this is very important to identify the capacity that we need to obtain in our system. Long term is also another very important element in an archive system. So the legal regulations in the governments establish that we need to archive sometimes forever a data. So there is no deadline. We need to keep it for a very long time. We need to reuse it if possible. And this is the long-term specifications. The cost is also a very important element of the data archiving media. The cost is established by the initial cost of a system and then a running cost, the so-called total cost of ownership, where many elements contribute to the total calculation. For example, air conditioning, if we need to condition a certain area where we keep the media stored, electric power, if these are spinning disks, for example, and required to be powered all the times, and the maintenance, if we need to put offline a system, or if we need to replace a hard drive or a set of hard drives, how much this will cost in terms of time, of cost. This is all contributing to the TCO, the total cost of ownership. The security is also a very important element, so our media needs to be, our solution needs to be really secure, otherwise it's pointless to archive data for such a long time. We need to guarantee that there is no data alteration, that the data stays the same, that we cannot risk to lose any data. And probability, we can add many things on top of the security slide. Okay. So a true archive solution should fulfill at least these three elements. Should be based on a very safe and secure media, should rely on very reliable products, possibly on a wide range of solutions, and be also able to be used in a solution. So not just only a media where to store and retrieve the data, but also should be able to offer the possibility to be part of a solution, of an ecosystem. We at Sony developed the ODA. The ODA was developed in 2013, and this cartridge is based on optical technology. We all know that future is unknown by definition, but today we know that the optical is readable even along 30 years ago. So we started developing compact disc in 1982, and today we know that we can still play back or retrieve this data recorded with the very long time ago, over 30 years ago, 1982, with the latest available technology of today. So optical has the best expectation to be something that we can read in the future more than any other possible technology. Today we have already introduced generation 3. Each cartridge has a capacity of 5.5 terabytes. And what is very interesting of this technology from Sony is that this technology, the ODA, is a natively warm technology. So it is very similar to the Rosetta Stone recording. Okay, once we write the data on an ODA cartridge or drive or cassette, it is impossible by any means to modify the data that has been written. So we compare this to the Rosetta Stone, just to make a comparison. We are using a recording film, it's oxide, it's a synthetic material. Then we guarantee 100 years that the data is stored safely inside this medium. So it's one of the very few natively warm technologies. So we use several strategies, and of course this is the large and long experience of Sony Corporation into the optical technology. In generation 3 of ODA we are using a double-sided disc and a triple layer approach. In this way we are able to record a large amount of data. We are recording using this type of strategy, so we are recording not only in the groove, but we are recording on the groove and the length of the surface. And there are several also approaches and technologies that we are implementing in the archival disk, using the archival disk technology in the ODA. So in the ODA, when we write the data, we also perform on-the-fly verifying. It means that while we write the data, we also read what we have just written, and we can guarantee that the data is continuously monitored and guaranteed for what is being written in that moment. In this way, we guarantee a very low bit error rate of 10 to the minus 25, which is at the moment is the highest level of security for the data. So this technology is a very, very, very safe technology. Regarding the products articulate among a very wide possibility. We have standalone drives. This is the 380U is a standalone drive which can be connected in USB 3 to any operating system, which will see this as a new volume. And this drive can read and write, of course, the new cartridges of generation 3 and has the full compatibility with all the previous generations. We then have a legacy of libraries. This is actually an example where we reach 2.9 petabyte, but combining the modules among a maximum number of 6 modules, we can actually make our library perform more in terms of speed or in terms of capacity. So we can combine different models of modules and achieve what we want to achieve for our archive system. We are now extending also to the enterprise libraries, and this is an example of our new EX enterprise library. This is a drawing. And with this generation 3 we can reach up to 50 petabyte of amount which is really very, very huge. Also, the libraries can, of course, be stacked in many, so achieving virtually any level of capacity. So we have, of course, talking about systems or solutions, we have achieved several projects worldwide. This is an example of something we made with Atempo, in an existing Huawei, of course. In an existing system, we have just shown that we can integrate our Sony ODS R30 library systems in order to guarantee or add the long-term storage to this existing system. So there is a full compatibility, the full capability from Sony Corporation to develop glue software to connect our library to any existing system. We have another example here where a large amount of data is being processed, and we of course can demonstrate the full capability to integrate a long-term archive solution, a long-term archive part, or even for some specific data where the long-term, cold term is required, we can create a separate silos where we store these very precious, very expensive, valuable data on the Sony optical disk archive solution. So it can be integrated in any existing system whenever we identify some particular data that needs particular care, particular attention, and the characteristics of the ODAs, 100 years warm storage, we can add to existing system this Sony library and achieve this technology. Sony is a worldwide corporation. We have hundreds of locations, offices around the world, and this is why we can offer more than any other company a presence worldwide for service, for support, for developing solutions together with all of you. I thank you for the attention, and I'm fully available to fulfill your further questions anytime. Thank you very much.
Big data requires a big brain, and AI is proving the most effective way to unlock its hidden value. Indeed, as Dr. Huawei is about to explain, AI-powered storage has a huge part to play in infrastructure innovation.
Hello. Today I will discuss how we can exploit the synergy between storage and AI. Storage and AI are closely tied to each other by means of big data. AI is driven by big data, which is diverse and has been growing exponentially. And big data needs to be persisted and maintained in storage systems. Advances in storage systems can make AI processing much more efficient and scalable. AI techniques, on the other hand, can be embedded in storage systems to optimize their operations. Exploiting the synergy between storage and AI entails using AI to empower storage and using storage to accelerate AI. Let's first look at how AI can be used in storage systems. Data center operations in general and storage management in particular are becoming ever complex due to the explosive growth of data and the proliferation of applications. Companies face many challenges for operations and maintenance. Service rollout takes a long time. Resource utilization is low. Problem resolution is passive and reactive, and the service level cannot be guaranteed. The net is that operational expenses are very high and account for 65% of the total cost of ownership. In Huawei, we have developed a solution called DMS for the intelligent management of data infrastructure. DMS supports autonomous operations and reduces operational overhead by embedding AI across 3 tiers: the cloud tier, the data center tier, and the device tier. On the cloud tier is the e-service cloud-based management system. E-service provides a cloud portal for around-the-clock monitoring and reporting. It can be accessed anytime, anywhere, and from any end-user device, including mobile devices. It also collects asset and operational data from registered data centers and uses the data to train AI models for predictions and diagnosis. On the data center tier is the DME product. DME automates the management of data center infrastructure as a whole. It uses the AI models trained by the e-service and manages the entire life cycle of the infrastructure. Finally, on the device tier, AI chips and algorithms are built into our storage products to enable self-learning and self-optimization and to simplify system configuration. At the next level of detail, the e-service that implements cloud AI aggregates resource and usage data from global data centers and builds a variety of machine learning models. These include empirical models, interaction models, efficiency models, and fault models. These models can be used for health assessment, diagnostics, capacity planning, and fault prediction. The models are then shared with data centers for optimizing data center operations. To date, the e-service has been independently deployed in 3 major regions of Huawei Cloud: China, Mexico, and Germany. It has accumulated more than 2 petabytes of training data, as well as AI models that support over 1,000 deployment scenarios and detect over 2,000 fault modes. Equipped with such data and models, the e-service is able to predict disk failures over the next 2 weeks and automatically create service tickets to track disk replacement. It is able to predict storage needs for the next 12 months and give detailed expansion recommendations. It is also able to successfully diagnose 93% of the problems. Data center AI is enabled by the DME product. DME automates the lifecycle management of the data center, including planning, deployment, operations, and optimization. Specifically, it uses SLA requirements and best practice templates to assist data center planning. It enables remote deployment and automated provisioning of the data center infrastructure. It recognizes scenarios of interest, conducts predictive analysis and root cause analysis, and performs mitigation and rectification in real time. It also continuously optimizes data center performance and reclaims unused resources. DME performs data analytics and AI inference based on data collected on the data center resources. It is able to reduce capital expenses by 20%, improve deployment efficiency by tenfold, automatically handle 60% of the faults, and increase resource utilization by 80%. Device AI is implemented on storage devices. The AI chip is based on Huawei's own DaVinci architecture for AI acceleration. It uses neural network and base network AI algorithms and builds custom machine learning models for different workloads. Specifically, device AI actively analyzes and understands I/O patterns, implements intelligent caching and prefetching, and improves cache hit rate by 50%. It supports deduplication, both inline and ex post facto, and achieves 80% data reduction. It also detects SLA risks in real time and triggers corrective actions to mitigate the risks. Further, device AI simplifies the deployment process. It reduces the deployment process from 15 to 3 operations and shortens deployment time by up to 90%. In addition to optimizing device performance, each storage device also propagates operational data to the data center level so that the data center can be automatically managed as a whole. GaussDB is Huawei's flagship database product line. GaussDB is an AI-native database and is based on the massively parallel processing architecture. It embeds AI capabilities to realize self-tuning, self-diagnosis, and self-healing. It is able to improve tuning performance by 60% via its self-tuning algorithm. That level of improvement is applicable to online analytical processing, online transaction processing, and hybrid transaction and analytical processing scenarios. It also harnesses the power of diversified computing, including x86, ARM, GPU, and NPU, in order to deliver extreme performance for AI and big data workloads. In the industry standard TPC-DS benchmark test, GaussDB outperforms other vendor products and delivers 50% better performance than the industry average. Let's switch gear and talk about how storage can accelerate AI. In general, building production-grade AI solutions is very challenging. According to industry analysts, only less than 10% of AI pilot projects reach full-scale production, and just a quarter of companies have revenue-generating production AI systems. One reason for this situation is the proliferation of siloed tools. Today, data is spread across disparate data stores, SQL databases, NoSQL databases, graph databases, file systems, object stores, etc. There are also many data analytics and machine learning engines out there, each suitable for different scenarios. In addition, a large number of tools need to be used when building an AI application. Those tools require deep expertise and skills, which are not easily available in the solution team. The integration of these tools is time-consuming and relies on glue code, and often incurs a lot of overhead and technical debt. We have been developing a data virtualization approach to tackling the tooling silos in data processing. Our effort spans 3 layers: data processing abstraction, data acceleration, and data orchestration. The data processing abstraction layer adopts a global namespace for all data sources. It exposes both declarative and procedural interfaces for accessing and processing all modalities of data, structured, semi-structured, and unstructured. The interfaces are independent of data sources and any specific data processors. The data acceleration layer implements the abstract interfaces by pushing down processing to off-the-shelf analytics engines, which could be distributed geographically. A wide variety of engines can be deployed and leveraged for batch processing, stream processing, query processing, and machine learning, respectively. The acceleration layer orchestrates the work performed by the analytics engines. It also performs optimization, such as the adaptive caching of indices and results. The data orchestration layer moves data and compute closer together for better performance. It uses techniques such as intelligent prefetching, near data processing, and adaptive partitioning. Overall, our data virtualization substantially simplifies development. It reduces development time by masking the heterogeneity of data sources and analytics engines. Meanwhile, it respects the separation of compute and storage and optimizes data processing performance. We also take a holistic approach to building business AI applications. AI applications involve a lot more than just machine learning. In fact, there are three distinct building blocks for AI applications: data pipelines, model pipelines, and insight pipelines. Data pipelines are processes that integrate data from heterogeneous sources and produce data sets to be used by machine learning. Model pipelines are processes that train and tune machine learning models based on the data sets. Insight pipelines are processes that derive business insights from data analytics and model inference. Today, developers have to use separate platforms to develop those pipelines. In an innovation project called Wenju, we provide a solution platform for business AI. The Wenju platform handles all three kinds of pipelines in a uniform manner and offers end-to-end visibility to the entire AI solution. In addition, the solution platform addresses many production-related issues that cut across these pipelines, such as infrastructure automation and optimization, data and model governance, continuous integration and delivery, and hybrid multi-cloud enablement. Wenju is a first-of-a-kind platform that provides a one-stop shop and an integrated experience for all members of a solution team. It allows data engineers, data scientists, machine learning engineers, software engineers, and IT engineers on the solution team to collaborate effectively. It holds the promise to significantly improve time to value for business AI. Conceptually, the Wenju platform encompasses three layers. The bottom layer is infrastructure management. It provisions various environments and deploys data and AI tools either on premises or on the cloud using out-of-box automation scripts. It also optimizes infrastructure resources based on service level objectives. The middle layer is asset management. It uses a unified framework to manage and govern all AI artifacts, including datasets, models, and code. It provides a catalog of AI artifacts, maintains the traceability of artifacts, and monitors the quality of datasets and trained models to ensure trust. The top layer is pipeline lifecycle management. It supports the development and operations of data pipelines, model pipelines, and insight pipelines in a consistent manner. It also simplifies development by providing higher-level abstractions. While it leverages existing data and machine learning frameworks, Wenju hides the details of interaction with those frameworks and thus bridges skill gaps in the solution team. In conclusion, there's excellent synergy between storage and AI. Exploiting such synergy will improve the performance and operations of storage and data infrastructure and will improve business by accelerating the development and execution of AI solutions. Thank you.
Flash storage is now mainstream, and all-flash storage is the fastest area of growth in the storage industry. With our range of Ocean Store Dorado all-flash products, we're eager to help drive this forward, and our commitment extends even further. Our Flash Ever program, launched last year, offers unprecedented levels of after-sales support to any enterprise looking to make the switch. Let's turn to Huawei Principal Architect Dr. Ning Wu to learn more about the Flash Ever program in 2020.
Hi, today I'm honored to introduce you Huawei's new Flash Ever program for Ocean Store Dorado storage platform. As you probably noticed, Huawei's Ocean Store all-flash platform has been through several stages of evolution. The Ocean Store's flash strategy was first introduced in 2017 and replaced 15K SAS HDD with SSD. In 2019, with the flash-only program, Ocean Store Dorado V6 was launched and 10K SAS HDD was replaced with SSD. In the same year, the Ocean Store Dorado Array had the #1 growth rate in the all-flash storage industry. In 2020, to further reduce TCO and help you benefit from the all-flash technology, Ocean Store Dorado is launching the Flash Ever program. The Flash Ever program has two services. The Effective Capacity Guarantee service guarantees the effective capacity the user will get, so you can focus on your business needs without being concerned about the data reduction details, such as compression and deduplication. The Ever New Device service protects customer investment by refreshing the storage hardware when needed, so you can lower your hardware refresh costs. So, in 2020, what exactly is the Huawei Flash Ever commitment? What do we mean by Effective Capacity Guarantee and Ever New Device service? Let me explain the program in details. The Flash Ever program was designed to protect your storage investment in an agile way, thereby reducing the TCO of the storage system. The Effective Capacity Guarantee service eases many of the customer concerns when adopting the all-flash technology. The purchase process can be simplified. Buy what you need, and you will have the guarantee to have the effective capacity that you purchased. You can use the storage as a service and leave the complexity of calculating data reduction ratios to Huawei. The Ever New Device service protects customer investment by refreshing the storage hardware when needed. The storage components, like building blocks, can be individually replaced, so you can stay on top of the latest hardware cycle. With this new effective capacity guarantee, you can play the need of IT hardware investment. For example, in the next 10 years, and only purchase what you need now. Because the effective capacity is guaranteed, you can plan based on the quotation per TB and the effective capacity that you need for your business. Then, gradually purchase and add more capacity when your business grows. If at any time of the process, the guaranteed capacity is not reached, Huawei will supplement capacity for free. This guarantee never expires for the full lifespan of the system. The Flash Ever program provides the best warranty for effective capacity because it covers the full lifespan, whereas some other vendors put a time limit on the warranty. For example, if a vendor puts a 6-month limit on a warranty, once 6 months passed and the effective capacity is not reached, customers will have to pay for any disk supplement. Under the same situation, because of the full lifespan guarantee, Huawei will provide customers free disk supplement. The same pattern may happen multiple times during the lifespan of the system. With the Flash Ever program, customers can rest assured that there is no additional cost incurred in the disk supplement process. Now let's look at the Ever New Device Service. It provides the investment protection for hardware. The program ensures that the hardware upgrade is free and old parts will be recycled by Huawei. For example, if you're using Ocean Store Dorado Generation X now, in a couple of years, once the Generation X Plus 1 is available, you will be able to upgrade the Gen X array to Gen X Plus 1. There is zero data migration needed in between. And similarly, a couple of years down the road, you will be able to upgrade from Gen X Plus 1 to Gen X Plus 2. The Ocean Store Dorado Flash Ever program will make sure you have the latest technology in your platform and at the same time reduce your replacement investment in storage. Let's see how the Ever New Device Service achieved it. In the past, a system refresh will require purchase of a new system. After lengthy installation and tuning, the data of the old system had to be migrated into the new system. With the Ever New Device Service, Huawei will replace the legacy controllers with the new controllers and replace legacy DAEs with new DAEs. Therefore, the Flash Ever program turned a month-level process into an hour-level process. In addition, there is zero data migration and there is no service disruption during the process, thereby saving customers all the migration cost and time. In summary, Huawei Ocean Store Dorado V6 is an AI-powered storage system with high performance and high reliability. Ever fast, ever solid, AI-powered. Now in 2020, Huawei is providing the effective capacity guarantee and the Ever New Device Service. The Flash Ever program is making the Dorado array even better. Thank you very much for your time. Goodbye.
Thanks for joining us on day 3 of Huawei's Industrial Digital Transformation Conference. If you'd like to watch any of our live casts again, they'll be available very soon, right here. And of course, you can also explore the latest in ICT and more at e.huawei.com. I hope that I'll see you again tomorrow, and thanks for joining us today.